Hi, this is Dharani Murali and you are watching part 1 of His Math series. And at this last video, we discussed exercise 3.2 of this third chapter, pair of linear equation in two variables. In that exercise, we discussed the substitution method for solving the pair of linear equation in two variables. Okay. In this video, we are going to learn the elimination method for solving this pair of linear equation in two variables. So this we will learn through the exercise 3.3 questions. Okay. Now let's get into the chapter. The first question reads that solve the following pair of linear equations by elimination method and the substitution method. So in this first question we are asked to solve the given pair of linear equation by elimination method as well as substitution method. Okay, we will solve these equations by both the methods one by one. Okay, so in the first subdivision of this question, the equations given are x plus y equal to 5 and x minus 3y is equal to 4. Whenever we are solving the linear equation pair by elimination method, in the first step we have to see that whether any of the two variable has same or equal coefficient in both the equations. Okay, so here if we see, for x both the equations have coefficient 1. Okay, so coming to the variable y, it has 1 as coefficient in equation 1 and minus 3 as coefficient in equation 2. Okay, so here we will use the x variable for elimination. So first we are writing both the equations here, and whenever the two coefficients have the same sign in both the equations, we will subtract the equations. Okay, here what we are doing equation 1 minus equation 2. Okay, but whenever the coefficients of the variable with equal coefficients have opposite signs, then we will add the two equations. Okay, here since both are positive, both are of the same sign, we are subtracting equation 1 minus equation 2. So let's see, while subtracting, the signs of the coefficients of second equation will be changed. So plus x will become x, minus 3y will become plus 3y, and plus 4 will become minus 4. Okay, so x minus x will get cancelled, and coming to the y part, y plus 3y, we will get 4y, and 5 minus 4 is 1. Okay, so what we will get, y is equal to 1 by 4. This is the y value. For getting the x value, what we will do, we will substitute y value in any one of the two equations and we will get the answer. So here we are substituting it in the first equation, x plus y equal to 5, x plus y equal to 5. So x plus 1 by 4 equal to 5. Taking this 1 by 4 to the other side, we will get x equal to 5 minus 1 by 4. Here we are taking LCM. So 5 into 4 by 4. Okay, so what we will get, 20 minus 1 by 4. So here x equal to 19 by 4. Okay, so here we have solved these equations by elimination method. Now let's solve it also by substitution method. Okay, so from the first equation we are taking x equal to 5 minus y. Okay, this value of x we are going to substitute in equation 2 in place of x. Okay, so what is equation 2? X minus 3y equal to 4. So in place of x we will put 5 minus y minus 3y is equal to 4. On simplification we will get 5 minus 4y equal to 4, minus 4y is equal to 4 minus 5, minus 4y equal to minus 1, which is nothing but y equal to minus 1 by minus 4. When we cancel out the minus sign on numerator and denominator, we will get y equal to 1 by 4. Okay, if we check, we have got the same answer through elimination method also. Now to obtain the x value, we are going to substitute this y value here in x equal to 5 minus y. So x equal to 5 minus 1 by 4. By taking LCM we get x equal to 20 minus 1 by 4, which is nothing but x equal to 19 by 4. Okay, so here also we are getting the same answer as that of the elimination method. This is how we will perform the elimination method and substitution method for any pair of linear equation in two variables. Now coming to the second subdivision, the equations given are 3x plus 4y is equal to 10 and 2x minus 2y is equal to 2. Okay, so what we will do, in the first step we will check whether any of the two variables has same coefficient in both the equations. Here x has 3 in the first equation and 2 in the second equation, and y has 4 in first equation and 2 in second equation. So both the variables does not have equal coefficient or same coefficient in both the equations. So what we will do now, we will multiply both the equations with numbers such that we get the same or equal coefficient for any one of the variables. Here y has minus 2 as coefficient in second equation and it has 4 as coefficient in first. So what we can do, if we multiply the equation 1 by 1 and equation 2 by 2, we will get 4y in the first equation and minus 4y in the second equation. Okay. So what we will do? We will do equation 1 into 1 and equation 2 into 2 we get. The equation 1 we will get as it is. 3x plus 4y is equal to 10. And for the second equation, the entire equation will be doubled. That is 4x minus 4y is equal to 4. Here if we see, here it is plus 4y and here it is minus 4y. Okay. For eliminating the y variable, we are adding these two equations. So we get 3x plus 4x equal to 7x plus 4y and minus 4y will get cancelled and 10 plus 4 is equal to 14. So x equal to 14 by 7 and x equal to 2. Okay. Now to obtain the second variable, what we will do? So if you see here, we are substituting it in the second equation. 2 into 2 minus 2y is equal to 2. Okay. That is what we are doing here. We are putting 2 in place of x. So what we will get? Minus 2y is equal to 2 minus 4 and minus 2y is equal to minus 2 and y is equal to 1. Okay. So here we have solved these equations by elimination method. Now we will solve the same equations in the substitution method and we will check whether we are getting the same answers. Okay. So what we will do? We will take the second equation. We will get 2x equal to 2 plus 2y and we can take 2 as common out and we can cancel it in the LHS and RHS. Okay. So what we will get? X equal to 1 plus y. Okay. This value we are going to substitute in equation 1. So what we will do? 3 into 1 plus y plus 4y is equal to 10. That is what we are doing it here. Okay. So 3 plus 3y plus 4y is equal to 10. 3y plus 4y will be 7y and 10 minus 3 will be 7. So y equal to 7 by 7, which is nothing but y is equal to 1. That is what we have obtained here through elimination method also. Okay. Now to find the x value, what we will do? We will put this value here in x equal to 1 plus y. So x equal to 1 plus 1 and x equal to 2. So that is what we have obtained in the elimination method also. Okay. So here we have got the same solutions as that of the elimination method through substitution method also. So with this we are completing the second subdivision. In the same pattern we are going to solve two more subdivisions of this first question. Okay. Now let's proceed to the third subdivision. Now coming to the third subdivision, the equations given are 3x minus 5y minus 4 equal to 0 and 9x equal to 2y plus 7. Okay. Clearly we can see that both the equations are not in the general form. Okay. So first we have to bring it to the general form. So what we are doing? 3x minus 5y is equal to 4. We are rearranging the first equation and writing it as 3x minus 5y is equal to 4. Now coming to the second equation, we will bring this y variable term to the other side and we will put it in the general form like 9x minus 2y is equal to 7. Okay. So now for solving by the elimination method, what we have to do in the first step, we have to check whether any of the two variables have equal coefficients, numerically equal coefficients in both the equations. So here we can see that both the variables does not have any equal coefficients in both the equations, but the x variables have coefficients one as the multiple of other. Okay, so what we can do here, we can simply multiply equation 1 by 3. So 3 into 3 we will get 9, and for the second equation we can multiply by 1. That is, we can keep the second equation as it is. Okay, so what we will do? First equation into 3, that is 9x minus 15y equal to 4 into 3, 12. Okay, so keeping the second equation as it is, we get 9x minus 2y is equal to 7. Here we can see x has 9 as coefficient in both the equation, but the sign is same here. So what we will do? We will subtract the second equation from the first. So here the sign will change for each term in the second equation. So what we will get here? Minus, plus, and here it is plus 7, so it will become minus. Okay, so 9 minus 9x, the x term will get eliminated, and minus 15y plus 2y we get minus 13y, and 12 minus 7 is 5. So what we will get? Y equal to 5 by minus 13 and y is equal to minus 5 by 13. Now to obtain the x value, we will substitute this y value in any of the two equations and we will get the x value. Here I am substituting the y value in the equation 2. Okay, see 9x equal to 2y plus 7, right? So what we will do? 9x equal to 2 into minus 5 by 13 plus 7. By taking LCM we will get 9x equal to 2 into minus 5 minus 10 plus 13 into 7, 91 whole divided by 13. 91 minus 10, we will get 81 by 13. Okay. So both the side we are having 9 multiple, so we can cancel it out. 9 into 9 is 81. So x value we will get 9 by 13. Okay. Now let's solve the same set of equations by substitution method. So what we will get from equation 1, we can get x equal to 4 plus 5y by 3. Okay. This x value we are going to substitute in the equation 2. Okay. 9 into 5y plus 4 by 3 equal to 2y plus 7. So what we will do? Here 3 is in the denominator, so we can cancel it like 3 into 3, 9. So what we will get? 3 into 5y, 15y, and 3 into 4, 12. In the RHS we are having 2y plus 7. So what we will get? 15y minus 2y is equal to 7 minus 12, which is nothing but 13y is equal to minus 5. And by taking this 13 to the other side, we get y is equal to minus 5 by 13, and this is the same value we have obtained through elimination method also. Okay. So now let's find the x value. We are substituting this y value, that is minus 5 by 13, in this place, that is x equal to 5y plus 4 by 3. So what we will get? X equal to 5 into minus 5 by 13 plus 4. Here we will multiply these two terms and here we will take LCM. Okay. So what we will get? Minus 25 plus 52 whole divided by 39. How we are getting 39? We will multiply 13 with 3, so we will get 39. Okay. So what we will get? 52 minus 25 is 27 and denominator is 39. Both are multiples of 3, so we can cancel it like 3 into 9, 27, and 3 into 13, 39. Okay. So we are getting x equal to 9 by 13, and this is also the same value which we have obtained through elimination method. So with this we are completing this third subdivision. Now let's see the fourth one. In the fourth subdivision, the equations are given using the fraction terms. So what we will do? First we will take LCM and simplify this equation and put it in the general form. So what we will do? Here the first equation is x by 2 plus 2y by 3 is equal to minus 1. So how we will take LCM? We will multiply this term by 3 by 3 and this term we will multiply by 2 by 2. Okay, so what we will get? 3x plus 4y is equal to minus 6. Okay. Now coming to the second equation, we will get 3x minus y is equal to 9. So this is how we are finding the general form of these two equations. So we are getting 3x plus 4y is equal to minus 6 and 3x minus y is equal to 9. Here if we check the coefficients of the variables, x has the numerically equal value in both the equations as its coefficients. Here since the sign of the coefficients of x variable in both the equations are same, we will subtract equation 2 from 1. Okay. So what we will do? Equation 1 minus equation 2, here the sign will change. Plus 3x will become minus 3x, minus y will become plus, and plus 9 will become minus. So what will happen? The x term will get cancelled, or we can say the x term will get eliminated. 3x minus 3x, this term will get eliminated. 4y plus y is 5y, and minus 6 minus 9 is nothing but minus 15. So y equal to minus 15 by 5 and y equal to minus 3. Now to obtain the x value, we will substitute this y value in any one of the two equations. So we are substituting it in equation 2. We will get 3x minus of minus 3 equal to 9, which is nothing but 3x plus 3 equal to 9. While taking it to the other side, we will get 3x equal to 9 minus 3 and x equal to 6 by 3, which is nothing but x equal to 2. Okay. Now let's solve the same set of equations by substitution method. From this equation 2, we can get y is equal to 3x minus 9. How we will get? We will bring this 9 to this side, 9 to this side, and y to the other side. We will get y is equal to 3x minus 9, and this value we are going to substitute in this equation. So 3x plus 4 into 3x minus 9 is equal to minus 6. On simplification, we will get 3x plus 12x minus 36 equal to minus 6. 15x is equal to 30, which is minus 6 plus 36, which is 30, and 15x equal to 30, x equal to 30 by 15, and x equal to 2, which is the same value we have obtained through elimination method also. Now to obtain the y value, we will substitute this x value here. Okay. So what we will get? Y is equal to 3x minus 9, y is equal to 3 into 2 minus 9, which is nothing but y equal to 6 minus 9 and y is equal to, this is also the same value which we have obtained through elimination method. With this subdivision, we are completing the question 1, okay. In second question, we will be seeing the statement problems, okay. Now let's move on to the second question. Till then, if you are watching this channel for the first time, do subscribe this channel and click the bell icon so that you don't miss any updates from this channel. If you are directly watching this video for this third chapter pair of linear equation in two variables, for you people, I will add the link of the other two videos, that is introduction video with exercise 3.1 and the substitution method video which contains exercise 3.2 in the comment section, and you can check it out from there. Now let's move on to the second question. Now coming to the second question, it reads that form the pair of linear equations in the following problems and find their solutions if they exist by elimination method. Okay. In this second question, the statement problems will be given and we have to frame the pair of linear equations and then solve them by elimination method if the solutions exist. Okay. So now let's see the first subdivision. If we add 1 to the numerator and subtract 1 from the denominator, fraction reduces to 1. It becomes 1 by 2 if we only add 1 to the denominator. What is the fraction? Okay. So here two conditions are given. This is the first condition and this is the second condition. Okay. With these two conditions, we will now be framing two linear equations and we have to find the fraction. In the first step, let us assume that let the fraction be x by y. Okay. So now after finding the linear equations, if we find the solutions for x and y, we can put it in the fraction form and give the final fraction. Okay. Coming to the first condition, if we add 1 to the numerator and subtract 1 from the denominator, the fraction reduces to 1. Okay. So we are adding 1 to the numerator, that is x plus 1, and subtracting 1 from the denominator, that is y minus 1. Okay. The fraction reduces to 1. Now with this condition, by cross multiplication method, we are going to find the linear equation. So what we will get? X plus 1 is equal to y minus 1, and bringing the variables to the one side and constants to the other side, we get, this will be our first equation. Now coming to the second condition, it becomes 1 by 2. Here it refers to the fraction, original fraction. It becomes 1 by 2 if we only add 1 to the denominator. So here we are adding only 1 to the denominator, keeping the numerator as it is. So what we will get? X by y by 1 is equal to 1 by 2. Okay. Again by cross multiplication, we will get 2x is equal to y plus 1, and bringing the variables to one side, we get 2x minus y is equal to 1, and this will be our second equation. Now to solve these two equations by elimination method, first we have to check the coefficients of the variables. So here if we check, the numerical value of the y variable in both the equation is same, that is minus 1, and it is of the same sign also. So what we will do, we will subtract equation 2 from equation 1. So what are we doing? This is equation 1, x minus y equal to minus 2, and this is equation 2, 2x minus y is equal to 1. While subtracting, the sign of the second equation terms will be changed. So plus 2x will become minus 2x, minus y will become plus y, and 1 will become minus 1. So x minus 2x will be minus x, minus y plus y will get eliminated, and minus 2 minus 1 will be minus 3. Okay. So minus x will be equal to minus 3 and x equal to 3. So we have found out the numerator part of the fraction. Okay. Now coming to the denominator or the y value, we will substitute this x value in any one of the equations. Here we are substituting it in the first equation. So what we get? X minus y is equal to minus 2, and we are putting x value here. 3 minus y is equal to minus 2, minus y is equal to minus 2 minus 3, and y is equal to 5. Okay. So our fraction is 3 by 5. Okay. So we have found out the required fraction 3 by 5, which is the solution of this question. And with this, we are completing this subdivision 1. Okay. Now let's move on to the second subdivision. The second subdivision reads that 5 years ago, Nuri was thrice as old as Sonu. 10 years later, Nuri will be twice as old as Sonu. How old are Nuri and Sonu? Okay. So here we are going to calculate the ages of Nuri and Sonu, and we are given two conditions. Okay. One is related to 5 years ago and another is related to 10 years later. So here first we are making a table where we are going to note down the present age 5 years ago, the age 5 years ago and 10 years later of Nuri and Sonu. Okay. So we are making a tabulation like this. We are considering the present age of Nuri to be X and Sonu to be Y. Okay. So we are going to find X and Y. That is the present ages of Nuri and Sonu. 5 years ago their ages will be X minus 5 and Y minus 5, and 10 years later their ages are going to be X plus 10 and Y plus 10. Okay. So now coming to the condition, 5 years ago Nuri was thrice as old as Sonu. So we are going to consider this column. Okay. So X minus 5 will be equal to 3 into Y minus 5, because 5 years ago Nuri's age will be thrice as old as Sonu. On simplification we will get X minus 5 is equal to 3Y minus 15. Okay. So we will get X minus 3Y is equal to minus 10, and this is going to be our equation 1. Coming to the second condition, 10 years later Nuri will be twice as old as Sonu. So we are going to consider this column now. So we will get X plus 10 is equal to 2 into Y plus 10. That is 10 years later Nuri's age, that is X plus 10, will be twice as old as Sonu. That is 2 into Y plus 10. On simplification we will get X plus 10 is equal to 2Y plus 20 and X minus Y is equal to 10, which will be our equation 2. Okay. Now we are going to solve these two equations by elimination method. So in the first step we are going to check the coefficients of the variables. Here we can clearly say that the coefficients of x variable in both the equation is 1, and also it is of the same sign. So what we will do, we will subtract equation 2 from equation 1. While subtracting, what will happen? The signs will change for the equation 2. Plus x will become x, minus 2y will become plus 2y, and plus 10 will become minus 10. So what we will get, x and minus x will be eliminated. Minus 3y plus 2y will be minus 5, and minus 10 will be minus 20, and we are getting minus y is equal to minus 20 and y is equal to 20. Okay. Now to find the value of x, we are going to substitute this y value in equation 1. So what we will get, x minus 3y is equal to minus 10, x is equal to minus 10 plus 3y, and x is equal to minus 10 plus 3 into 20. 3 into 20 will be 60. So x will be equal to 60 minus 10, which is nothing but 50. So we have considered x to be Nuri's age and y to be Sonu's present age. So Nuri's present age is 50 years and Sonu's present age is 20 years. With this we are completing the second subdivision. Now let's move on to the next question. Now the third subdivision reads that the sum of the digits of a 2-digit number is 9. Also 9 times this number is twice the number obtained by reversing the order of the digits. Find the number. Okay. Now let us assume the number to be xy. So how we will write this 2-digit number? We will write it as 10x plus y, since this is 1's digit and x is 10's digit. Okay. For example, if we take 62, okay, we can write this number as 6 into 10 plus 2, which is nothing but 60 plus 2, 62. So this is the way we are representing this 2-digit number xy also here. Okay. Now let us see both the conditions given. Okay. Coming to the first condition, the sum of the digits of a 2-digit number is 9. Here the digits are x and y. Y is 1's digit or the units digit, and x is the 10's digit value. Okay. And x is the 10's digit. So what we will do? X plus y is equal to 9. We will take this equation to be equation 1. Coming to the second condition, it is given 9 times this number is twice the number obtained by reversing the order of the digits. Okay. If we reverse the order of the digits, the number which we will obtain is yx, which we will write it as 10y plus x. So what are we going to get? 9 into this number, 9 into 10x plus y will be equal to 2 times the number obtained by reversing the digits, which is nothing but 2 into 10y plus x. On simplification, we will get 90x plus 9y will be equal to 20y plus 2x. Okay. Now bringing all the x variables to one side and y variables to the other side, we get 90x minus 2x, which is 88x, and 20y minus 9y, which is 11y. Here 88 is divisible by 11, so we can cancel it as 11 into 8, 88. So we get 8x equal to y. Here if you see, directly in place of y we can substitute 8x in this equation and we can obtain the x and y values. But here we cannot do that because it is specifically given that we have to solve the solutions by elimination method. If we substitute this value in place of y here, then it will become substitution method. Okay. So to proceed with the elimination method, what are we going to do? we will write it in the general form like 8x minus y is equal to 0, and we are going to take this equation as equation 2. Now considering equation 1 and equation 2, we can see that the numeric value of the coefficients of y variable is 1 in both the cases, and it is also of the opposite sign. Here the coefficient of y is plus 1, and in the equation 2 the coefficient of y variable is minus 1. Okay. If the coefficients are of opposite signs, what we will do? We will add both the equations. So here also we are going to do equation 1 plus equation 2. That is what we are doing here. Equation 1 x plus y is equal to 9 plus equation 2 8x minus y is equal to 0. While adding, there will be no sign change in the second equation. So directly we will add x plus 8x equal to 9x, plus y and minus y will get eliminated. So we will get 9 plus 0 is equal to 9. So what we will get? X equal to 9 by 9, which is nothing but 1. Coming to the y value, we can substitute this x value here. That is y is equal to 8x. So y is equal to 8 into 1. We will get y is equal to 8. Okay. So first we will check it with this 10x plus y. That is 10 into 1 plus 8, which is nothing but 18. We can write it as xy. We can write xy as 1 8, that is 18. Okay. So this is the 2-digit number which we require here as the solution. Okay. With this we are completing this third subdivision. Now let's move on to the fourth one. Now the fourth subdivision reads that Meena went to a bank to withdraw rupees 2000. She asked the cashier to give her rupees 50 and rupees 100 notes only. Meena got 25 notes in all. Find how many notes of rupees 50 and rupees 100 she received. Okay. This is what we have to find here. We have to find the number of notes of rupees 50 and rupees 100 Meena has received. So in the first step, let us assume, let the number of rupees 50 notes be x and let the number of rupees 100 notes be y. Okay. So here we have got two conditions. First, let us take this condition. Meena got 25 notes in all. Okay. So x plus y will be 25. We will take this to be equation 1. Now coming to the second condition, Meena went to a bank to withdraw rupees 2000. Okay. So the total amount she has withdrawn is 2000. What we will do? Rupees 50 into number of rupees 50 notes and 100 into number of rupees 100 notes. That is 50x plus 100y will be 2000, and this will be our equation 2. But before marking equation 2, let us simplify it little more. Since 50, 100 and 2000 all are divisible by 50, we can divide this entire equation by 50. Okay. So what we will get? X plus 2y is equal to 40, and we will take this to be equation 2. Now for solving by the elimination method, we have to see the coefficients of equation 1 and 2, and here clearly x variable has the same coefficient in both the equations. So we can directly proceed. X plus y is equal to 25 and x plus 2y is equal to 40. Here the coefficients are of the same sign. So what we will do? We will do equation 1 minus equation 2. Whenever we subtract the equation 2 from 1, the signs of the terms of equation 2 will be changed. So plus x will become minus x, plus 2y will become minus 2y, and plus 40 will become minus 40. Here since we are getting plus x and minus x, the variable x will be eliminated, and we are proceeding by y minus 2y is equal to minus y, and 25 minus 40 will be minus 15. So we are getting minus y is equal to minus 15 and y is equal to 15. Okay. Now for obtaining the x value, we can take the equation 1. X plus y is equal to 25, x equal to 25 minus y, and we know that y is equal to 15, so we will get x equal to 25 minus 15, which is nothing but x equal to 10. So now we can conclude by saying number of rupees 50 notes received is 10 and number of rupees 100 notes received is 15. Okay. With this we are completing this fourth subdivision. Now let's move on to the fifth subdivision. Coming to the fifth subdivision, the question reads that a lending library has a fixed charge for the first 3 days and an additional charge for each day thereafter. Sarita paid rupees 27 for a book she kept for 7 days, while Susie paid rupees 21 for a book she kept for 5 days. Find the fixed charge and the charge for each extra day. So what we have to find? We have to find the fixed charge and we have to find the charge for each extra day. So in the first step, we are assuming let the fixed charge be x, let the charge for each extra day be y. Okay. So first condition we will take, Sarita paid rupees 27 for a book she kept for 7 days. The fixed charge will remain the same in every case. So what we will do? X plus 4y. Here we are taking 4y because for the first 3 days it is included in the fixed charge, and for the remaining number of days only the charge per extra day will be calculated. Okay. So here, since she has kept the book for 7 days, we will minus this 3 here, 7 minus 3. So x plus 4y is equal to 27. And coming to the second condition, while Susie paid rupees 21 for a book she kept for 5 days. So the fixed charge includes for the first 3 days. So for the remaining 2 days, we will add the charge for each extra day. So what we will get, x plus 2y is equal to 21. Here we will take these two equations as equation 1 and equation 2. Here, if we see the coefficients of the variables, x has the coefficient of same numerical value in both the equations and the sign is same. So what we will do, we will subtract equation 2 from equation 1. While subtracting, the signs will change. So plus x will become minus x, plus 2y will become minus 2y, and plus 21 will become minus 21. So what we will get, x and minus x will get cancelled. So x variable is eliminated here, and we will get 4y minus 2y is equal to 2y, and 27 minus 21 is 6. Y is equal to 6 by 2 and y is equal to 3. For finding the x value, what we will do, we will substitute this y value in equation 2. So x plus 2y is equal to 21. On rearranging, we get x equal to 21 minus 2y. Here we know that y is equal to 3, so we are substituting it here. We will get x equal to 21 minus 2 into 3, which is nothing but x equal to 21 minus 6 and x equal to 15. Here we have taken the fixed charge to be x. So fixed charge will be equal to rupees 15, and charge for each extra day is equal to y. So the charge for each extra day is equal to rupees 3. With this subdivision, we are completing this second question, and also we are completing this exercise 3.3 of this chapter. And not only that, we are also completing this chapter pair of linear equations in 2 variables with this question. Okay. For those who are using the previous edition books, I'll tell you, this exercise 3.3 is exercise 3.4 in the older edition book. Also, since the cross multiplication method and the equations reducible to the pair of linear equation in 2 variable form is also deleted. The exercises 3.5 and 3.6 are also deleted in the previous edition book. Okay. So with this, we are completing this chapter. Let's once again meet in the next video for the discussion of previous year asked Cbse board questions from this chapter pair of linear equation in 2 variables. Until then, bye bye.